Hi guys, this video is on Section 2-4 on deductive reasoning using the laws of detachment and syllogism. We already talked about the law of detachment in class, and I'm going to do a very short summary of it again to get it fresh in your mind, and I'm going to add one little correction. The law of detachment says that if we have a true conditional statement and then the hypothesis is given to us about some specific case, then we can conclude that the conclusion must be true about that specific case. There's a word that needs to be in this definition up here, or this statement up here, that's missing, and we need to put it in. It says, given a true conditional statement, that's the word that needs to go in there. Given a true conditional statement. So if our original statement isn't true, it doesn't matter what anybody tells you. If the conditional statement says, if it snows, then it's 80 degrees outside, that's not true, obviously. If it snows, then it's 80 degrees, and somebody says, it's snowing, well, who cares if it's snowing, because their original statement about the temperature outside is not true. So if the original statement is true, and then if somebody tells us that the hypothesis part is true about some specific case, then we know that the conclusion that is supposed to follow about that specific case is also true. So for example, we did this one about Mark saving money and being able to buy a video game. And it helps to label things with letters so you can see what's going on. The part that comes after the word if is the hypothesis. And if the hypothesis in a true conditional statement is true, then the conclusion is naturally supposed to follow. So if this hypothesis is true about Mark, which down here in the second sentence it says that it is, Mark does save $30, so the P part, the hypothesis part, does actually happen, then the conclusion, the Q part that is supposed to follow, we can assume will naturally follow in Mark's case. So we can conclude that therefore he can buy the video game. Let's take a look at example 2 on this page. What if we're told this? If a quadrilateral is a rhombus, then it is also a parallelogram. A rhombus is a thing that looks like this, where all four sides are the same length. Okay, so if a quadrilateral is a rhombus, then it's also a parallelogram. Underline the stuff that comes after the word if. That's the hypothesis, kind of like our P. And underline the stuff that comes after the word then. It is also a parallelogram. That's our Q. This is our true conditional statement. Now they tell us something else. A certain quadrilateral called ABCD is a rhombus. So this is true. The P part is true about this particular case. Then we know that the Q part that's supposed to follow is also true. So we can say that ABCD is also a parallelogram. I have an abbreviation for parallelogram. I write the parallel symbol and put ogram. Is also a parallelogram. Okay. Number 3, we concluded there was nothing valid we could say. Why not? Well, because we were given this not P. So we had if P then Q. And they gave us the opposite of the P. And we remembered that the inverse, this is the inverse of the original statement. And the inverse isn't necessarily true, just because the original is true. So we can't conclude if not P, then not Q. That doesn't work. All right, let's take a look at number 4. If the sum of the measures of two angles is 90 degrees, then they're complementary. So after the word if, that's the P part. The sum of two angles is 90. After the then part, they're complementary. That's our Q. What do they tell us? They tell us we have two angles, J and K, and their measures are 58 and 32. Let's see. It's 58 and 32. Does that add up to 90? 2 is 10. Yes. So they add up to 90. So this part about the measures adding up to 90 is true about angles J and K. So this is the P part. So we know that Q is supposed to follow, so we can say that this Q statement is true about angles J and K. They're complementary. So we can say angle J and angle K are complementary. Okay? And then number 6, remember why there was no valid conclusion? We were trying to reason backwards with the converse. We said if you plan to attend, then you buy a ticket. That's this statement, if A then T. She purchases a ticket. She does the T part. And this line of reasoning that we're supposed to be following in the law of detachment only goes in this direction. It doesn't go backwards following the lines of the converse. It's kind of like a river where everything flows one direction. So you can reason in this direction following the arrow, but you can't go backwards. That would be the converse, and it doesn't always work. All right, so there's no valid conclusion. Yes, might she be going to prom? Maybe, but we can't conclude for sure that she is. All right, so that's the law of detachment. If P then Q, P is true, therefore Q must be true. We have one more kind of law of thinking that we're going to use throughout the year in trying to show that things are true in geometry. It's called the law of syllogism. And syllogism is what you see in if you give a mouse a cookie, or if you give a moose a muffin, or something like that. So if you do this, then this is going to happen. That second thing, if that happens, then something else is going to happen as a result of that. And then something else is going to happen as a result of that. So you get this chain of events. And then if you started happening in the first place, everything's going to happen. You're going to know that the ending thing is going to happen as a result. So it's kind of like a bunch of dominoes that all fall. Okay, that's the law of syllogism. It's kind of like the transitive property. Like if A equals B and if B equals C, well, then you've got this kind of bridge here. And you know for sure then that A equals C. So it's kind of like the transitive property. All right, the law of syllogism says this. If P then Q, so some if-then statement, and then we take this Q that was the conclusion of the original if-then statement and make it the hypothesis of another statement. If Q happens, then something else is supposed to happen, like R. And then we know if we start with the first thing, we'll end with the last thing. So our conclusion is going to be, therefore, if P happens at the beginning, then we can follow this chain of events, and as a result, R will happen. If P, then R. Okay, that's the format of the logical argument. Notice it's a bunch of if-then statements, which is different from the law of detachment. It's only one if-then statement, and then two separate things. Notice we've only got two letters to work with here. We've only got two things, a hypothesis and a conclusion. And we're just saying the same things over and over, just those two things. In the law of syllogism, we get a third kind of thing introduced. So we have P, Q, and R involved. Let's fill in the blanks here. The law of syllogism allows you to draw a conclusion from two or more conditional statements in which the conclusion of the first statement, like Q here, is the hypothesis of the second statement, like Q right here. Okay, that's the law of syllogism. Let's take a look at a few examples. It says, draw a valid conclusion. Valid means it follows this line of thinking. It follows this order of argument. Okay? Remember, we can only follow the arrows in one direction. We can't try to swim upstream and try to go backwards and use the converse because it doesn't always hold true. All right, number 6. It says, if it is Saturday, then Jake has a baseball tournament. So let's underline, it is Saturday, that's our P. And Jake, underline the stuff that comes after the word then. Jake has a baseball tournament, that's our Q. The second statement says, another if-then statement. If Jake has a baseball tournament, then he'll need to pack his lunch. So underline the stuff after the if. Jake has a baseball tournament. Is that the same thing we had before? It is. So that's Q again. Then he'll need to pack his lunch. That's a new thing. So he will need to pack his lunch. That's our new thing. We'll call it R. So this is the form of the argument. If P, then Q. If Q, then R. And this ending here is repeated at the beginning here. So that's the correct form of the argument. We can conclude that if P, then R. So therefore, if P, then R. In words, it would say, if it's Saturday, then, just like somebody just closed a door outside my window and my dog is growling. He's going to bark for us. Just a second. All right. Sorry. If it's Saturday, then the last thing, he will need to pack his lunch. And you can abbreviate. He will need to pack his lunch. Okay. Number 7. Let's see if there's anything we can conclude or if it doesn't follow the argument correctly. Let's see. If a number is divisible by 12, then it's divisible by 6. So a number is divisible by 12, that's going to be our P. It's divisible by 6, that's our Q. If P, then Q. If a number is divisible by 6, that's repeated, that's our Q again. Then it's divisible by 3. That's a new thing, so that's R. So we have if Q, then R. You don't have to write this stuff off to the side, but it seems to help sometimes to see the letters instead of all the words. That's the correct form of the argument, so we can conclude, therefore, if P, then R. So if a number is divisible by 12, if a number is divisible by 12, then we can conclude the last thing must follow. It's divisible by 3. Okay? I wouldn't write this stuff out like this for any other real situation, but in our notes for our purposes, it serves the purpose. Let's see if number 8 works. Excuse me. If a quadrilateral is a square, then it's a rectangle. So if it's a square, if P, then it's a rectangle, then Q. If it's a rectangle, then it has 4 right angles. Is it repeated? Is this our Q? If a quadrilateral is a rectangle, yes, that's our Q. So this is a new thing, it's our R. So this works too. If P, then Q, if Q, then R, therefore, if P, then R. What would the final statement look like? If a quadrilateral is a square, then it has 4 right angles. Like that. All right. Number 9. If it's sunny this weekend, then you'll go boating. So let's label. It is sunny this weekend would be our P. After then, you will go boating as our Q. The second conditional statement says, if it's sunny this weekend, then you'll wear shorts. So we've seen it is sunny this weekend before. Is that our Q? No, that's the P that we had above it. That's P again. So it's this form. If P, then Q. If P, then you'll wear shorts. That's R. We don't have this repetition here. So if it's sunny outside, several things are going to happen, but we can't make a conclusion. We don't have this chain of events like the mouse and the cookie or the moose and the muffin or the chain of dominoes. So that doesn't work. So what we would say is there's no valid conclusion that we can draw. We can't be certain that anything is the case. So we say no valid conclusion. Okay? All right, let's try this one more together. If you shop at Target, then you'll use your Target red card. I guess a credit card of some sort. So you shop at Target would be the P. You will use your Target red card as the Q. So if P, then Q. If you do not use your Target red card, well, our Target red card was the Q, but now we have the not version of it, the negation of it. So you do not use your Target red card as not Q. If not Q, then you will not get 5% off. Not, let's see, that's a new thing, right? So let's use a new letter. Let's use R, not R. That doesn't follow our law of syllogism pattern at all. We do have the Q repeated here, but it has to be just Q the way it appeared in the first statement. We can't negate it. That doesn't work. So this is a nothing. No valid conclusion. Now, don't overthink this. Like, well, in the real world, this could be the case. If you don't use your card, we're trying to say for sure that this is going to be the case. We're trying to say that we have an actual valid conclusion that by these laws of thinking, we can really conclude. So there's some scenario in which this may be the case. We want to know in every single case, using our laws of deduction, that this would actually be a good conclusion. And there is no good conclusion we can draw here that would always be true. Okay? All right, you try number 11, and then I'll put up my answer, and we'll see how you did. All right. This is what I got. It is a valid argument. We can draw a valid conclusion based on this, because if P then Q, if Q then R, our Q is repeated in the hypothesis of the second statement after it showed up in the conclusion of the first statement. So that's a valid form of reasoning. So we can say if it snows, the students will need to make up a day of school. All right, let's do a little bit of practice identifying which is which. So the law of detachment is the one that has one if-then statement and then just a plain old statement about some specific case. And then we can say that the conclusion must follow about that specific case. The law of syllogism has an if-then and an if-then, and then the conclusion is an if-then. Okay? It says determine whether the conclusion follows, really validly, from the given statements by one of these two laws. If it does, state which law was used. And if it doesn't, we'll just state that it was invalid, the conclusion they tried to make wasn't really valid. Number 1, if they tell us, if I drive over the speed limit, that's our P, then I will get a ticket. They tell us that I drive over the speed limit. Uh-oh. Which letter is that? That's our P, about me in some specific case. So if P is true, we know that Q is supposed to follow if this original statement is true, which they're telling us it is. So if the P part's true, the Q part has to follow. So I got a ticket. What was supposed to follow? Yeah. If P then Q, P came true, therefore Q happened. Yes, that is a valid conclusion by the law of, which one? Detachment. It's this one. We'll abbreviate. Law of detachment. All right, number 2. If Amanda goes to the restaurant, Amanda going to the restaurant is our P, then she'll order a hamburger, that's our Q. If she orders a hamburger, hey, we've seen that before, that's our Q. Then she'll get fries, that's our R, that's a new letter. If P then Q, if Q then R, we should be able to draw a valid conclusion. Let's see if they did it correctly. They should have said if she goes to the restaurant, she'll get fries. If she goes to the restaurant, she'll get fries. Yes, that's a valid conclusion. It's if P then Q, if Q then R, therefore, if she goes, then she'll get fries. So, law of syllogism. All right, now that you've got it figured out, let's try 3 quickly, and then I'll let you try some on your own. Number 3, if it snows, I'll wear my boots. If it snows, that's our P again. That doesn't look good. I won't go to school. So if P then Q, if P again, then some other letter. We see P twice, but it doesn't appear in the right spot. We don't have this chain of events. We just have P making lots of different things happen. So there's no valid conclusion we can draw. So if they try to say, if I don't go to school, then I'll wear my snow boots. They're trying to say, if not R, then I'll wear my snow boots. Then Q. There's no validity to that at all. There's no pattern that they're following. They're just making stuff up. So we'll say this is an invalid conclusion that they tried to draw. Okay, you try numbers 4 and 5, and I'll put up my answers for you. All right, here's a different version of my worksheet. Number 4, they've used the law of detachment correctly. If she goes to the beach, she'll wear sunscreen. If she does go to the beach, therefore she's supposed to wear sunscreen. So that's a valid conclusion to draw, is that she wears sunscreen. Number 5 is an invalid conclusion they tried to draw. If you get a cold, you eat soup. If C then S, or if P then Q. So-and-so ate soup. They did the last part, but the reasoning doesn't necessarily flow in the opposite direction. If we try to do this, if we try to say that S implies C going backwards, you can read my little note that curves around, we're using the converse of the original conditional statement, and it doesn't necessarily always hold true. So remember, if the conditional is true, its converse isn't necessarily always true. All right, there's one more page to take a look at. Take a look at number 6. If 2 angles form a linear pair, I'm on page 20. If 2 angles form a linear pair, then they're supplementary. If they're supplementary, then their measure is 180. Is that a valid conclusion according to the law of syllogism? Yes, it is. It looks like this. Okay. If they're a linear pair, then they're supplementary. We say that same thing again. If they're supplementary, then they're 180. So therefore, we can start at the beginning and follow the chain of events to the end. If they're a linear pair, then they add up to 180. Okay? And number 7, the last one, if she gets at least a 95, then she'll get an A. So if she gets a 95, she'll get an A. She got a 98. So she got at least a 95. So she satisfied this first part. So can we conclude that she got an A? Yes. That's what's supposed to follow. So by the law of detachment. Okay? And then the last one, number 8, is an invalid conclusion. If it's raining, you must bring an umbrella. You bring your umbrella. They're trying to reason backwards, right? They're trying to use the converse. So that doesn't work. It's an invalid conclusion. All right. That's enough of that for now. We'll skip number 9, and I will see you guys in class. Send me your homework and ask me questions if you have them. See you soon.